Batteries are the new technology that could power the future. However, their production can be quite costly. Cobalt and nickel, two of the most basic components in current lithium-ion batteries, with the exception of LFP chemistry, are not only expensive, but are also supply constrained, as detailed in Elon Musk's famed master plan. This poses a great challenge to the fundamental purpose of developing electric vehicles using easily obtainable materials. As a result, Tesla, the world's largest producer of electric vehicles, is developing a unique battery chemistry that will address this issue. For many decades, scientists and researchers have spent a lot of time and effort looking into new viable raw materials that can be used in battery production. Graphene is one of these new materials, but it hasn't made any significant headway until very recently. A team of experts has just developed a new graphene battery that has the great potential of becoming the next generation battery that will power electric vehicles. This is Elon Musk Live, and today we're inviting you to join us as we explore Elon Musk's revolutionary new graphene battery. What exactly is graphene? How does a graphene battery work? And how does Tesla plan to utilize it? All these will be answered very shortly, but before that, please make sure to subscribe and hit that bell button if you want to stay up to date on all the latest news about Elon Musk, SpaceX, and Tesla. Tesla became the first automaker to commercialize an all-electric vehicle that uses lithium-ion battery cells when it launched the Roadster in 2008. Although many automakers had previously experimented with hybrid vehicles that use an internal combustion engine and one or more electric motors, the high cost of production largely disinterested them from all-electric automobiles. However, the era of combustion engines is now slowly coming to an end, while electric vehicles are fast approaching the moment where they will redefine the auto industry. Many consumers now prefer EVs, as they're much more efficient than hybrid vehicles, not to mention that they're better for the environment. In fact, governments are fully supporting long-range, zero-emission vehicles by offering subsidies and tax rebates. Regulatory supervision has also increased, much more notably in Europe, where they're promoting the rise of electric mobility in multiple ways. With this increasing demand, the global market for EVs is now projected to grow from 8,151,000 units in 2022 to 39,208,000 units by 2030, at a compound annual growth of 21.7%. To meet this demand, nearly every automaker is selling or plans to sell a vehicle that is either all-electric or at the absolute least hybrid. In November 2019, Ford introduced the all-electric Mustang Mach-E, which is part of the company's previous $11 billion plan to build 40 all-electric and hybrid models by 2022. That investment is now increased to $50 billion through 2026 in an attempt to catch up to the current industry leader Tesla. Ford's chief executive Jim Farley said that the company plans to build more than 2 million EVs in 2026. Volkswagen, on the other hand, has announced that it will invest $7.1 billion to produce battery electric cars in North America, and it will offer 25 new EV models to customers in the US, Mexico, and Canada by 2030. This rapid growth in electric vehicle production means that the need for electric batteries is also increasing. Lithium-ion batteries are a type of rechargeable batteries that are widely used in many electric vehicles. When electric vehicles didn't have lithium-ion batteries, driving ranges were limited and charging periods were long. But thanks to lithium-ion batteries, cars can now go farther between charges. The only downside is traditional lithium-ion batteries are too heavy. They make electric vehicles heavier than vehicles powered by internal combustion engines. They also take a long time to charge and are costly, making them out of reach for many people. Additionally, lithium metal batteries have big challenges when it comes to chemistry. During charging, traditional lithium-ion batteries, which use liquid electrolyte solution, move lithium ions from the cathode to the anode. When the anode is made of lithium metal, dendrites, which are needle-like structures, form on the surface. These structures grow like roots into the electrolyte and pierce the barrier separating the anode and the cathode, which shorts out the battery. In the worst-case scenario, it may even cause the battery to catch fire. Temperature change can also cause swelling, while external factors can cause leakage, making lithium batteries prone to a lot of battery damage. The development of solid-state batteries, which use solid electrolytes, can solve these issues. A solid-state battery is made up of thin layers of solid electrolytes, which makes them safer and more stable than lithium-ion batteries with liquid electrolytes, which can become unstable and flammable at high temperatures. Solid-state doesn't have a risk of explosion or fire, and it also offers higher energy density than a lithium-ion battery. However, this also makes solid-state batteries more expensive. So, what should be done to improve the battery technology for electric vehicles? The answer to this is graphene batteries. What is graphene? Graphene is an atomic-scale hexagonal lattice made of carbon atoms. Seen as the wonder material of the 21st century, graphene boasts many exceptional characteristics. Graphene is a superb conductor of heat and electricity, as well as a fascinating light-absorbing material. It conducts electricity better than copper and is impermeable to gases. Having only a single layer of carbon atoms, it's 200 times stronger than steel but 6 times lighter, making it the strongest and thinnest substance known to man. Further, its properties can be altered when chemical components are added to its surface. Graphene is a wonderful substance that offers many practical uses in many fields. It can be mixed with other elements like gases and metals, yielding a wide variety of compounds with superior qualities. Graphene is being studied and patented all over the globe to discover its numerous features and possible applications. These include transistors, computer chips, supercapacitors, solar panels, LCD, and even DNA sequencing. One of its applications that many scientists and researchers are looking into is its potential application for batteries. The subject of graphene-based batteries has garnered a lot of attention in the field of battery research. Touted as the next step in battery development, the graphene battery is expected to eliminate several issues with lithium-ion batteries. Graphene has high porosity, large surface area, extraordinary strength, and low density. In addition to its great charging capacity and flexibility, it can make for excellent thermal and electric energy conductors, making them ideal for energy storage. Graphene's excellent electrical conductivity can also increase the electrode density in batteries and produce faster chemical reactions, which can boost power transfer while reducing heat. Graphene is also less prone to deterioration than lithium, allowing EV batteries to last significantly longer. That said, there are also other companies interested in the idea of graphene batteries that might someday power EVs. Nanotech Energy is developing graphene-enhanced batteries for portable electronics and EVs. Recently, a Taiwan-based financial services business called Fubon Financial Holding made a $64 million investment in the company. There's also the Spain-based Graphene, together with a Chinese partner, said to be developing a graphene polymer-based battery that would allow for a range of up to 500 kilometers and a recharge time of under 5 minutes. EarthDOS is a Spanish startup that has made a graphene battery that charges electric motorcycles and bikes in only 5 minutes. Additionally, in 2020, Chinese EV maker GAC Group announced the development of a graphene-enhanced battery that can be charged up to 85% in 8 minutes. With these many companies already investing in creations of many types of graphene-based batteries, I'm sure it's only a matter of time before Elon Musk and Tesla also announce their own version of graphene batteries. In fact, back in 2014, a Chinese news outlet published an article stating that Tesla is working on a graphene battery that could nearly double the range of Model S cars to 500 miles. Elon Musk himself gave credence to this news by saying that he thought it would be possible to create an EV with 500 miles. They can do it soon, but it would increase the price. This checks out, as obtaining materials of high quality remains an issue for many developers. There is also the lack of mass production techniques for manufacturing high-quality graphene batteries. Additionally, the production of graphene can be very costly, with 1 kilogram of graphene ranging between tens and thousands of dollars, which is substantially higher compared to the production cost of activated carbon at $15 per kilogram. However, for many innovators like Elon Musk, these are just small hurdles that will need to be overcome in order to produce extraordinary results. Musk has done it before with Tesla's very own Roadster. While many automakers were hesitating to invest in fully electric vehicles Musk went right ahead and released the Roadster, marking the very beginning of the EV era. We have no doubt that it will be the same for graphene batteries. Being the richest man on the planet, Elon Musk has the capital to inject into the research and development of this next-generation battery. And it will only be a matter of time before this graphene battery that will power all EVs will come into existence. Tell us what you think about this advanced battery in the comments section below. And if you like this video, then don't hesitate to hit that thumbs up. Thank you for watching. We'll see you next time.